Alright guys, in this video we continue on 3.2 probability distribution for discrete random variables to talking about the cumulative distribution function. So before talking about the definition of cumulative distribution function, let's take a look at example first. So I will give an example given the probability distribution. So we have the probability distribution down here. So of course, a probability distribution contains all of the possible values of this random variable and the probability of each possible value. So in this case, x could be 0, 1, 2, 3, and 4. And the probability of x is equal to 0 is 0.2. And then 0.25 for x is equal to 1, 0.3 for x is equal to 2, 0.15 for x is equal to 3, and then 0.1 for x is equal to 4. And then I put it in a table. So this is a probability distribution. We have the probability distribution here. And then what I want to figure out is the probability of x is less than or equal to 2. So based on the probability distribution over here, if I want to find the probability of x is less than or equal to 2, what kind of x value could be? Okay, we just need to see which value or which values are less than or equal to 2 in the probability distribution. So if x is less than or equal to 2, x could be 0, 1, 2. In other words, the probability of x less than or equal to 2 is equal to the probability of 0 plus p of 1 plus p of 2. Right? So which is equal to 0.2 plus 0.25 plus 0.3, which is 0.75. Right? And then what if I want to find the probability of x is less than or equal to 2.7? And then same thing, we go back to the probability distribution and see what kind of values are less than or equal to 2.7. So still those three numbers 0, 1, and 2, because 3 is greater than 7. 3 is greater than 2.7. So in other words, in this case, the probability of x is less than or equal to 2.7 is going to be equal to the probability of x is less than or equal to 2, which is 0.75. Right? And then what is the probability, let's say x is less than or equal to 2.9999. So if x is less than 2.9999, what kind of values x could be? Same thing. Still 0, 1, and 2. X cannot be 3 because 3 is greater than 2.9999. So in this case, the probability of x is less than or equal to 2.9999 is going to be equal to the probability of x is less than or equal to 2, which is 0.75. And then what is the probability that x is less than 2? We don't have an equal sign here. That means x cannot be equal to 2. So we just need to see what kind of x value is less than 2. In this case, it would be only 0 and 1. So the probability of x less than 2 is p of 0 plus p of 1, which is 0.2 plus 0.25, which is 0.45. So the probability of x is less than 2 is 0.45. And then what is the probability of x is less than -1? So same thing, we need to say what kind of values are less than -1 in the probability distribution. Do we have anything less than -1? I don't think so. So since we got no number less than -1, so the probability of this interval x is less than -1 is equal to 0. And then what is that the probability of x is less than 0? Same thing, we have nothing less than 0, so this will be 0 as well. And then what is the probability that x is less than or equal to 0? So in this case, x could be equal to 0. I will say there are only one number less than or equal to 0 in the probability distribution, which is 0. So this would be equal to the probability of x is equal to 0, which is 0.2. 0.2, not 0.25. 3.2. Okay, and then what is the probability that x is less than or equal to 4? Same thing, we just need to go back to the probability distribution and see what kind of values are less than or equal to 4. Now we can tell the x could be 0, 1, 2, 3, 4, and all of them are less than or equal to 4. That means the probability x is less than or equal to 4 is 1. Which means if we pick up number from the probability distribution, it must be less than or equal to 4. And then what is the probability that x is less than 6? Now, based on the numbers, the possible values of x in the probability distribution, we know that all the possible values are less than 6, so the probability of x less than or equal to 6, less than 6 is 1 as well. Now, there's one thing I would like to mention is that for discrete random variable, the probability that the random variable x less than a number little x is less than the probability that the random variable less than or equal to this number. Now we can tell from here, the probability x is less than 2 is 0.45, and the probability of x is less than or equal to 2 is 0.75. And then we can tell the 0.45 is completely different, it's completely less than 0.75. Why? It's because that the single point, the single possible value of this random variable matters. Okay, we can calculate the probability of a single point. Now in this case, that means we are adding the value x to this interval x is less than x to get this x is less than or equal to x. And that's why this is greater than that. And if we put this kind of probability in form of a probability capital F of x, we call it cumulative distribution function. Now let's take a look at the definition of cumulative distribution function. The cumulative distribution function CDF, shorthand version, and we're gonna use it a lot in this class. The CDF f of x of a discrete random variable x with a PMF of x is defined for every number x by the capital F of x CDF is equal to the probability that x is less than or equal to this little x. So that means this is equal to the sum of all probabilities that the possible values are less than or equal to x. For any number x, f of x is the probability. So if f of x is probability, then f of x must be between 0 and 1, inclusive. F of x is the probability that the observed value of x will be at most. So just always keep the idea in your mind. F of x is a probability, so that means it's always between 0 and 1, and f of x is equal to the probability of this right close interval for x. Okay, just always keep this idea in your mind. The cumulative distribution function, or CDF, is the probability of interval. Okay. Now, once this is clear, let's take a look at this example over here. This is from the textbook 3.13. A store carries flash drives with either 1, 2, 4, 8, 16 GB of memory. The accompanying table gives the distribution of y is equal to the amount of memory in the purchased drive. So, since this is distribution, we know that y could be 1, 2, 4, 8, and 16. So we get those 5 numbers here and the corresponding probabilities. You know, this is the distribution, the probability distribution. We get all of the possible outcomes and the probability of each outcome. Now, let's first determine f of y for each of the 5 possible values. So, since the possible values for y could be 1, 2, 4, 8, 6, let's take a look at what is the f of 1. So based on the definition, f of x is equal to the probability of x is less than or equal to x. So of course, f of 1 would be, f of 1 would be equal to the probability of x is less than or equal to 1. Just like, y. Y is less than or equal to 1. Just like what do we have over here. And since we only have one number for y less than or equal to 1, which is 1, so this is equal to probability of y is equal to 1, which is p of 1, which is 0.05. And the next possible value is 2. F of 2, of course, based on definition here, f of 2 is equal to the probability of y is less than or equal to 2, right? That's coming from the definition of cumulative distribution function. So this is the probability of y is less than or equal to 2. So now let's take a look how many numbers less than or equal to 2 in the probability distribution. We got 2 of them. So if y is less than or equal to 2, it could be either 1 or 2. So that would be equal to the probability of y is equal to 1 or 2. So that would be equal to the probability of y is equal to 1 plus the probability of y is equal to 2. So 0.05 plus 0.1 gave us 0.15 over here. And then the next possible value of y is 4. And based on the definition, we have f of 4 is equal to the probability of y is less than or equal to 4. Of course, we got 3 numbers in the probability distribution less than or equal to 4. They are 1, 2, and 4. So that would be equal to the probability of y is equal to 1 or 2 or 4. So which is equal to the probability of 1 plus probability of 2 plus the probability of y is equal to 4. So if we add those 3 probabilities together, we'll get f of 4 is 0.5. And then the next possible value for y is 8. And of course, based on the definition, f of 8 is equal to the probability of y is less than or equal to 8. And if we go back to the probability distribution here, we get 4 numbers less than or equal to 8. They are 1, 2, 3, 4. So that would be equal to, so the probability of y is less than or equal to 8 is equal to the probability of y is equal to 1 plus the probability of y is equal to 2 plus the probability of y is equal to 4 plus the probability of y is equal to 8. And then we add them all up. We have the value of y of 8 is equal to 0.90. And then the next value is 16. So f of 16 based on the definition is equal to the probability of y is less than or equal to 16. Of course, if you want to find this probability, you can just add those all probabilities together. Since it's a probability distribution, the sum of all probabilities is always equal to 1. So we get this probability is 1. And you can think of it in another way, which is that we can tell that all the numbers in the probability distribution are less than or equal to 16. There's no number greater than 16, right? So basically, if I randomly pick up number from the probability distribution, it must be less than or equal to 16. So the probability that y is less than or equal to 16 is equal to 1. Because it must be the number I pick up must be less than or equal to 16. Okay, so once this is clear, let's take a look at this. Now for any other number y, f of y will equal the value of f at the closest possible value of y to the left of y. For example, so what is f of 2.7? So based on the definition, we have f of 2.7 is equal to the probability of y is less than equal to 2.7, right? But we can tell there's no 2.7 over here, right? And we can tell there are only 2 numbers are less than equal to 2.7, which are 1 and 2. The third number is 4, which is greater than 2.7. We cannot count that. So the probability of y is equal to 2.7 is equal to probability of y is less than equal to 2. Of course, which is equal to f of 2, which is 0.15, as what we get over here. And we can also tell that the 2 is the closest possible value of y to the left of 2.7 in the original probability distribution. Okay, 2 is the closest possible value to the left of this number 2.7 here. And then let's take a look at this, f of 7.99. So we can tell that there is no 7.99 if we want to find out the probability of y is less than or equal to 7.999. So we got to find the closest possible value of y to the left of this number 7.99. So which is 4, right? Because 8 is greater than that. So in this case, y is less than or equal to 7.999 is equal to the probability of y is less than or equal to 4. because 4 is the closest possible value of y to the left of y. Okay, to the left of 7.999, and this is equal to f of 4. So this is equal to 0.50 as what we get over here. Okay, so just always keep the idea in your mind that just always keep the idea in your mind the CDF is the probability of an interval. Okay. And then let's take a look at the next example. Oh, it's not a next example. Actually, this part is continued. Is a continued example. 3.13. So once we have the value of the CDF, so we can build up the CDF. Okay, in the form of function f of y. Now, just always keep the idea in your mind that once you want to build up a CDF, the CDF always starts with the probability 0 and the probability 1. So those numbers here are the probabilities of the corresponding interval behind here. Now we can tell that the smallest possible value of y is 1. There's nothing less than 1. So for any number y is less than 1, the probability is 0. Okay? Of course, f of y is equal to 0 if y is less than 1, because there's no number less than 1 in the probability distribution. And then we start with the very first possible value, which is 1. So between 1 and 2. So we use a bracket for 1 and a parenthesis for 2. So 2 is not contained in this interval over here, because 2 is the left end of the next interval. So the probability of the first interval between 1 and 2 is 0.05, because for any number between 1 and 2, this is f of y is equal to f of 1 for x between 1 and 2. 1 for bracket, 2 for parenthesis, because that for any number between 1 and 2, let me see, f of y is equal to f of 1, because 1 is the closest possible value of y to the left of this number y. Okay, so for example, if y is 1.9999, then f of y is equal to, f of 1.9999 is equal to f of 1, which is 0.05. Okay, because the 1 is the closest possible value to the left of 1.9999. And then the next interval, we start with the second possible value of y, so between 2 and 4. 2 and 4. So this would be equal to f of 2, which is 0.15. Because this is equal to f of 1 plus f of 2. Okay? And the next one would be the probability between 4 and 8. So this would be equal to, I will say, let me rewrite it. So the first one is equal to f of 1, actually. And this is equal to f of 1 plus f of 2 plus f of 4. Oh, let me rewrite it clear. Plus f of 4. And the next interval, so this would be equal to f of 1 plus f of 2 plus f of 4 plus f of 8. And of course, this would be f of 1 plus f of 2 plus f of 4 plus f of 8. Okay? Now just always keep the idea in your mind. The CDF always starts with the probability 0 and ends with probability 1. And why this is called cumulative distribution function? This makes sense intuitively because every time we are adding one more value to the previous probability. So that means it keeps getting the value of the CDF bigger and bigger until it's equal to 1. That's why it's cumulative, because we're adding, one more number to the previous interval every time, just like that. And of course plus f of 16. Oh, I'm sorry. I messed up. Sorry. I'm sorry. I made a mistake over here. It should be the f. So the first one is right. Is the f of 1. This is the probability of y is equal to 1, actually. And actually, this is equal to f of 2. It's not f of 1 plus f of 2. I'm so sorry about that. I apologize for that. So this would be equal to the probability of y is equal to 1 plus the probability of y is equal to 2. Okay? And this is equal to f of 4, which is probability of y is equal to 1 plus probability of y is equal to 2 plus the probability of y is equal to 4. And this is equal to f of 8, which is probability of y is equal to 1 plus the probability of y is equal to 2 plus the probability of y is equal to 4 plus the probability of y is equal to 8. And this, the very last one, is equal to f of 16, which is equal to the probability of y is equal to 1 plus the probability of y is equal to 2 plus the probability of y is equal to 4, and then plus the probability of y is equal to 8, and plus probability of y is equal to 16. So the reason why it's called a cumulative distribution is that we're adding one more probability to the previous one to make the value of the CDF bigger and bigger until it's equal to 1 at the end. And I apologize for the mistake I just made. It should be the sum of the CDFs. It should be the sum of the probabilities. Okay. Now, once we know how to build up the CDF of this random variable, let's take a look at how the graph of this CDF look like. Now we can tell for the function value, since this is function, and of course the 0 is function value. Okay. The function value is always equal to 0 if y is less than 1. So to the left of 1, we have, this is equal to 0 to the left of 1. And then between 1 and 2, so this is 1, this is 2. Between 1 and 2, actually, the solid point should be over here. Here should be the open circle. This should be open. Because if this is 1, this is 2, f of 1 is supposed to be equal to 0.05. Okay? 0.05. So this should be the open circle. This is a solid circle. Okay? And then this should be open, and this is a closed. And f of 2 is equal to 0.15. So this is a 0.15 somewhere over here, 0.15. And of course, this should be the open circle, okay? And so forth. And when x is equal to 4, between 4 and 8, and the value of the CDF jumps to 0.5. So this is we should get the solid point over here, an open circle over here. And this is a 4, and this is a 8. And so forth. This should be the solid point, and this should be open circle, and this is solid over here. So that was a mistake in the textbook. So always solid on the left and open on the right. Okay? And we can tell this is a step function. For x, a discrete random variable, the graph of f of x will have a jump at every possible value of x and will be flat between possible values. Such a graph is called a step function. So step function means that the function value in each interval is the same. That's why it's got a kind of a horizontal line segment in each interval. It's all horizontal. Okay, so once we know this, let's take a look at how to find out the CDF with the given PMF here. Actually, we have seen this example in the previous video. The PMF of x is equal to the number of bursts, had the form P of x is equal to 1 minus p to the power of x minus 1 times p. That's the form of the PMF. For x is equal to all the integers greater than or equal to, well, excuse me, and 0 otherwise. Now, once we have the form of the PMF, let's take a look at how to find CDF here. Now, based on the definition, we have f of x is equal to the sum of y is less than or equal to this x, and then p of y. So this is a p of y. P of y. So that means that's the f of x is equal to the sum of all probabilities for which y is less than or equal to x. Now we just plug this back into here. So that would be equal to sum of y is equal to 1 through x, right? And then 1 minus p to the power of y minus 1 times p. Yeah, I think that's right. So since x could be y could be any number between 1 and x, and the power of y minus p is always just y minus 1, whatever the value of y is. And then we just need to take a look at what the summation of this geometric series look like. So we know that since the value of y doesn't matter with the p here, we can factor out of the summation. That would be equal to p times the sum of y is equal to 1 through x, and then 1 minus p times y minus 1. And then we know for the sum of geometric series, the sum of a geometric series is equal to a1 times 1 minus q to the power of n divided by 1 minus q. And we know that the q is a common ratio, right? Now, in this case, the common ratio is the q is equal to 1 minus p. And n is equal to x. Because we have x terms in total. We get x terms in total. Now, once we have the formula, we can find the sum. So that would be equal to, rewrite down the p here, and then times 1 minus q, which is common ratio. Q is 1 minus p, minus 1 minus p over here. And on the top, we're going to have the first term. The first term would be the term when y is equal to 1. When y is equal to 1, the power would be 1 minus 1, which is 0. So 1 minus p to the power of 0 would be 1. So we get the first term would be 1 times 1 minus q to the power of n. Q, the common ratio, is 1 minus p, and n is x. And then this would be equal to 1 minus 1 minus p to the power of x. How do we get that? We can simplify this a little bit. We can simplify this fraction over here. So on the bottom we have a p times, on the bottom 1 minus p would be p. And then on the top, we can just get rid of this 1 directly, because 1 times anything is just anything itself. It's going to 1 minus p to the power of x, right? So this p will be cancelled out, and we have 1 minus p to the power of x. Now, we can make the conclusion here, therefore, f of x is equal to 0. Of course, since the x must be greater than or equal to 1, so the value of a CDF would be 0 if x is less than 1, and then that would be equal to 1 minus p to the power of x for x is greater than or equal to 1. X is equal to 1, 2, 3, and so forth. So that's pretty much how we find the CDF. But as what I mentioned previously, I said that usually the CDF starts with probability 0 and ends with probability of 1. Now let's take a look at when f of x. Let me clean this real quick. Okay, let me clean this real quick. So the question is when f of x is equal to 1. When f of x is equal to 1. In this case. Now we have f of x is equal to 1 minus that 1 minus p to the power of x. So we get a 1 already here. If we want to make f of x is equal to 1, we just need to make this part, this exponential part, is equal to 0, right? So we get exponential form over here, and when this part is 0. Now let's take a look at the graph. Let's take a look at the graph of exponential function. We know for exponential function, it looks like this. If f of x is equal to a to the power of x, and a is greater than 1, that would be increasing function. And it would be decreasing if f of x is equal to a to the power of x, and a is between 0 and 1. So if a is between 0 and 1, and the exponential function would be decreasing, and when it's getting 0, it's going to be approaching to 0 infinitely when x is going to be infinity. So in this case, if x is going to be infinity, if x is going to, let me rewrite this. If x is going to be infinity, then f of x is equal to 1. Because when x is going to be infinity, the exponential part would be 0. 1 minus 0 will give us 1. Okay, so I have one more question. So with the given CDF here, if we don't know the PDF, well, I mean, if we don't know the PMF, I just gave you the CDF like this. Can you tell me how to find the probability of a single point? Like, what's the probability of, I don't know why it doesn't work well, the probability of x is equal to 2. So with the given CDF here, how can we find the probability that x is equal to 2? How? Now, think of this. I have already shown that. Let me clean this real quick. Let me clean this. So we know that the CDF is a probability of an interval, right? And if we go to number line, and this is a let's say this is 0, this is 1, and 2. Okay. Now the f of a 2, f of a 2 will give us the probability that x is less than or equal to 2. Right? But we want the probability of x is equal to 2. We don't want the probability that x is less than or equal to 2. Okay? So what do we need to do? We want to subtract this part. We want to subtract this part. Right? So this part, the probability of this interval is f of 1. Which is, I don't know why this doesn't work well. Let me clean it real quick. Okay, so we have that f of 1 is equal to the probability of x is less than or equal to 1. Right? So we can tell the probability x is equal to 2 is equal to f of 2 minus f of 1. Does it make sense? I wish it makes sense. Because f of 2 will give us the probability that x is less than or equal to 2. And this is the probability of x is less than or equal to 1. Because we're looking for the probability of the single point x is equal to 2. We don't want this. We don't want the probability x is less than or equal to 2. But that's the only thing we can find with the given CDF here. We can only find the probability of an interval. The probability of x is less than or equal to 2. So we want to subtract that. We want to use this minus the probability of x less than or equal to 1. We want to get rid of this part from this interval to get the probability of the single point x is equal to 2. And of course, we can find out those two values. We plug the 2 back into here, so that would be 1 minus p squared. And then minus 1 minus p. If x is equal to 1, the power would be 1. Okay, I wouldn't simplify it over here. I just want to show you how to find the probability of a single point for a discrete random variable. Okay. Now, once this makes sense, let's take a look at the next one. Let me clear this for a quick. I don't know why, for some reason, the screen doesn't work perfectly. I apologize for it. I think it might be because that I have recording this video is a little bit too long, and the screen just doesn't work perfectly if recording too long. But anyway, so once we have this, let's take a look at how to find the probability of an interval. X is greater than or equal to 2, less than or equal to 4. All right, so let's go to the number line again. So I will clean this part here and reread it. So in this time, we are looking for the probability that x is greater than or equal to 2, less than or equal to 4. So we go to number line, and then we got 2 here, and then we got 4 here. So we are looking for the probability of this interval, right? We're looking for this. But we cannot find this probability. We cannot find the probability of this interval directly with the given CDF over here. But what we can find is the probability of x is less than or equal to 4, right? And let me put a 1 over here. Let me put a 1 over here. So what we want is the probability between 2 and 4, but we cannot find it directly from the CDF. But what we can find out is the probability x is less than or equal to 4. We can find the probability all the way to the left of 4, right? And we want 2 in the interval here. What we need is we need to subtract all the way to the left of 1 from all the way to the left of 4. We don't have to worry about the gap between 1 and 2 because it's discrete. There's no way we can have a number x. We can have a number for between 1 and 2. So basically, we're gonna have this is equal to f of 4, which is all the way to the left of 4, which is minus f of 1, which is all the way to the left of 1. Okay, so this is not equal to f of 4 minus f of 2. You gotta really watch all this, okay? If we have a equal sign for the 2 here, we cannot subtract f of 2 because we want the 2 included in this interval. If we subtract f of 2, then the 2 is gone. It's gone. The 2 is not included in the interval if we minus f of 2 here. So if we want the 2 included in this interval, we need subtract f of 1. Okay, but what if, okay, I want the probability that, I don't know, it doesn't work well. The probability x is, let's say, greater than 2, but less than or equal to 4. In this case, this would be equal to f of 4 minus f of 2. Why? Because the 2, we don't have the equal sign over here, okay? We don't want the 2 included interval. We want to get rid of the, we want to get rid of the 2 from the interval. That's why we minus f of 2. So when you are looking for a probability of interval for discrete random variable, you got to really be careful with the boundary point over here, okay? So once this is clear, let's take a look at the proposition given down here. So for any two numbers a and b, with a is less than or equal to b, and then the probability of x is less than or equal to x is greater than or equal to a but less than or equal to b is equal to f of b minus f of a minus, where a minus represents the largest possible value, largest possible x value that is strictly less than a. So in particular, if the only possible values are integers, if a and b are integers, then the probability of x is greater than or equal to a but less than or equal to b, that is equal to, the probability is equal to a or a plus 1 or until b. That makes sense, right? That would be equal to f of b minus f of a minus 1. Okay, just like what we did over here. If we're looking for the probability of x is greater than or equal to 2 but less than or equal to 4, we want to use f of 4 minus f of 1 because we got an equal sign here. We want the 2 included in the interval, okay? So we subtract f of 1 here. But if we don't have the equal sign here, we get a minus f of 1 because we want to get rid of the 2 from the interval. Okay? So this is a minus 1. So you got to be really familiar with kind of stuff. You got to know how to find the probability of an interval with the given CDF. You will definitely say something about this in homework 4 and the first midterm exam you're going to have on Thursday. Okay? Now, taking A is equal to B yields that the probability of x is equal to a is equal to f of a minus f of a minus 1 in this case. So which is what we're doing here. So the probability of x is equal to 2 is equal to f of 2 minus f of 1. Okay. Okay, I think that's pretty much all about this video. And before ending this part, I just want to let you know that you got to be really careful with the boundary points of the interval here, and say if you want the endpoint in the interval or not, because they're completely different two things. And you got to be really familiar with how to find the CDFs with a given PMF, and how to find the probability of a single point or probability of interval with given CDF. That's really, really important, and you will definitely say something in the homework 4 and the first midterm exam. And if you have any questions about anything, please feel free to come to my office hours tomorrow or on Thursday. So I sent out the announcement last week about I will hold office hours. I mean online office hours since this Tuesday. Okay, I will have office hours every